So here's how real Murphy moves on the floats looks like. That's a fully assembled airplane which is flying, and I just decided to show it to you how it's gonna look like when the airplane in my hangar is ready. So which is pretty cool. You see how many windows it has? Huge doors. It's a really big airplane, eh? Tail. That's how all its system is done. For the floats control, for those guys. Look at this massive and huge elevator and rudder. Wow. That's really an airplane, eh? So, well, from the first look inside, I can say it's a huge amount of space here. Front seat's not even close to be set to the control sticks. Control column, it's a huge space. It has two garments, G3 axis, G5, GPS 175, and lots of other garment stuff, which is great. That's cool. Very nice setup. Those are the pedals, control pedals, which we actually just install it in our moves. So here how it looks. Oh, look at those. Those are actually the inspection panels for the rollers, for the cables inside. So let's take a closer look at the baggage space. So look at that. After the fourth seat, we have so huge space here. It's just a lot of space. And of course we have here that so-called compartment for the avionics and electronics. But you see how it's used here? They use it for batteries. They have two batteries here. But some customers, some pilots making this as a baggage compartment. Very interesting. So yeah, that's a huge airplane. So we need to actually rivet this airplane, right? Otherwise it won't fly. The riveting on this airplane is pretty much standard like any other airplane. I don't see much differences. We go with just standard 1410s, pull rivets, and any riveting, it includes the drilling. So of course, much drilling first of all. So of course we make sure it's on clickers, so all openings are matching, or holes are matching. So we're basically making sure that our backside surface is set properly. So we just do the drilling. The drilling, of course, have to be done with the according and correct drill bit, which in my case is 30. We have to do a deburring. That's very important on both sides. Why it's important? Because aluminum, if not deburred, aluminum can develop cracks. Those cracks are very tiny and you won't be able to see them obviously at the very beginning, but with the time cracks may increase in size and basically create an issue. We drill the hole, we deburr it, insert the rivet, and this time I'm using a pneumatic squeezer. We cannot call it squeezer, right? Like rivet gun. So I'm not really used to use that for riveting because, as many of you know, RV10 which I built was using the solid rivets, which is actually you use a backing bar and the gun to back it, to back a rivet, to rivet it. And it's way more complex because it takes more time, more preparation, and of course it takes lots of efforts to make it nice and perfect. But this airplane, luckily, it's easier to assemble. It's probably similar to RV12 and probably RV15, which using the same pull rivets. So yeah, after rivet is set, just making sure it's all set correctly, and you're good to go to the next one.
he's doing so well.
Yeah, I know.
Can I go?
No, you cannot.
Okay, I'll stay.
So, what?
What is this?
Okay, this is actually interesting.
So weird.
Well, that's
So hard to push it.
That's to attach something to something. Like, for example, you can go like this, and you can drag the whole box like this.
Let me try. Open it.
All right. Well, test fit. Looks cool, eh? The panel cut is ready. Now it's time for wiring. Lots of things I need to install here. This is just as a sample, the LM1000 installed. I mean, it's just attached with single bolt, but so far it looks good. So it's coming. Well, it's a Halloween today, so just having some fun here. Maria, what's wrong?
It's not going in.
It should.
It is.
Good. That's good. We have more kids here now. So it's like
Whoa.
we have very small kid and two
Hey, I'm not small.
bigger
I'm not small.
and two one size up. Alright, so we are moving forward on this project, and first of all, of course, we got the panels more or less cut and ready, so we can start to install avionics here. We already have some components installed under the panel. Now, importantly, what we have two wire guides for the wiring between the firewall, through the firewall, between the engine compartment and between the under the panel compartment. So here I use the fire sleeves. So once I pass the wires inside, I will close it up. So it's going to be safe. Here I have like those mounts on the firewall, so I can attach the sleeves. Well, it's same I did on my RV10 and it worked well for me. This part is for sensors, so we're gonna have at least two sensors, oil and fuel pressure, with the lines coming here. We can install sensors on the engine too, but it's better to have it here in my opinion. It's just easier. This will be the engine ground point, while inside we have the ground pad where we will be connecting all avionic grounds. Here we have a relay. This is going to be the starter relay, so we're basically going to run starter through this relay. We'll see how we're going to wire it up in this configuration, where it automatically turns on with the power here, or most likely it's going to be powered on and we're going to separately bring dedicated, for example, ground here. We will see. And that's our power line through Firewall for the alternator to battery. So basically battery will be in the back of the airplane, while here we will have the alternator comes here, and also the starter wire. This is our oil cooler. Again, this is from the RV. It should be fine here. Well, technically we should be totally fine here with the 90 degrees or even 45 degrees adapter. So it should be good. We still have to seal all those openings on the side. It's just preliminary fit, just to test, to try. Initially I was thinking to have battery here, but it's a bad idea, especially because battery cannot really sustain the temperatures over 190 Fahrenheit, 200 Fahrenheit. Under cowl it can be more, depends on the situation, right? Alright, so we're checking now how the fuel tank is fitting. Oh, actually it did fit. It's just perfect, eh? Yeah, it's just perfect.
Yeah, that's...
Wow. Just curious as to how many gallons we're gonna get in. Well, once it's done, we'll just measure it, right?
Yeah.
Cool. Nice. So we're gonna have 2 header tanks. So that's how our fuel tank, ready to go, one of the 2 header tanks, looks like. So it basically gets installed like that. Top inlet, that's for the gravity feed from the wing tanks. Now on the bottom, this likely will be the outlet, larger one, right? So this one will give us a fuel to the fuel selector and then to the fuel pump. And this is the return line. We're going to be returning back here. I guess no bubbling, it's pretty spread, so there should be no bubbling here. Yeah, well, that's basically it, and that's our fuel tank. And it's gonna look like exactly like this. Yeah, of course it's gonna be inside, but well, that's how it is. Maria, you ready to work on the airplane? Always ready?
Kinda.
Kinda, okay, good. So yeah, that's how it is. So while we moving slowly forward, camera just recording some parts of the process. So well, basically it's kinda the series of the videos where I just show the progress and probably explaining some parts of it. So well, now working on the panels, on the switch panel and on the circuit breaker panel. So far everything is good. We're missing a couple circuit breakers, not a big deal, not a showstopper, because we have a bunch of those breakers. They just not identically to what I have, so I prefer to have everything in the same form factor. It's just easier to work. Yeah, so well, that's how it is for now. Looks good. Well, I'm writing the whole book here, like quite a book for this airplane, with all electrical description and yeah, with everything literally. Today I also inspected the system, which is the SDS ignition system. Yeah, it's a 6-cylinder full system with everything. So well, I'm just very interesting to see how it's gonna work. Very interesting. I've never installed the system like this one, but I installed a similar system, which is FE32. SDS FE, I think it's called, from United States. Well, so we'll see how the system go. It's interesting, lots of parts. I must say that system comes pretty like solid parts, nice parts to have in the hands. From electrical engineer perspective, well made, good wiring, good quality wiring, I must say. We'll see how it works. Lots of parts in this system. I'm just getting myself familiar with it, but in overall it's interesting. So basically that's the system I was just talking about. I'm just looking at all the parts and bits, all the wires. Those are our panel, pretty much assembly is in progress. And of course my cup of tea, as always, with me. So the circuit breakers and bus bars, so that's That's still missing a couple breakers, but that's fine for now. We're working on the bus bars. What's important here to know? First of all, you obviously have to connect circuit breakers, depends on your lines, like Avionics bus, I mean depends on the type of buses you have, like Avionics bus or main bus, power bus, wherever the ignition system. Very important to select the appropriate size copper, like appropriate thickness copper bus bar. Okay, so what we now have? We have our panel almost ready for test feed. So we have a main entry point for the power from the battery, from the alternator. We have two bus bars which are for the main power for the airplane. We have a thick piece of cable here to connect those two. I was thinking to make it with a copper bar, but just to be honest, this is totally fine solution, and it's gonna work in the same way. It's a thick enough cable and comparable with those bus bars capability for the amperage. And we have a relay here, 40 amp relay to give the power to the Avionics bus, and that's going to be our control cable for the Avionics bus. Again, 40 amp according to my calculations should be totally fine. This airplane is quite rich on avionics, but at the same time the avionics installed is not that, doesn't draw that much current, that much juice. Alright, check that out. So that's an air inlet for the air, obviously. And how this is gonna work is inside we have the air guides, whatever it's called, and we have air inlet. So we just basically need to figure out some sort of a hose, or maybe even 3D printed something, and that should make it. So that should technically make it in a very nice way, and it's done on both sides very nicely. Here's our avionics shelf with various models. That's how it's going to be connected. A little bit mess here, but that's easy to clean. Importantly, that we have now those installed very nicely. I'm probably going to use some tank sealant here just to make it even better. So hopefully we're one more step closer now to engine installation. Actually, that's probably going to be. Alright, so now we work on the installation of the, well, everything. So literally we're working on the circuit breakers, on the switches, wires, ignition system. As you can see, lots of wires here. So what I did for now is I just used the tie wraps to hold the panel so I can easily pull it down when needed, leave it in this position, and access to the circuit breakers so I can actually connect the power lines. That's our SDS EFI system. Install it and I start pre-wiring it here. About SDS EFI, what I did not like, just to be honest, from my point of view. So installation manual, they need to provide schematics like these for all connectors, for everything. Like they do provide some schematics, like for example, they do provide this reference schematic how to connect power. That looks awesome, but put a color and pin number here. Color and pin number, which pin, which color. I understand they provide pre-wired harnesses, but human assembled that harness. Human can make a mistake. That's again important. That's an engine ignition system for the engine. This is gonna fly in the airplane, so I would prefer to check. So lack of schematic technical drawing. Maybe I didn't find it, but I went through all documentation they provide and was unable actually to find it. Aside of that, no issues. Like, well, they have pretty solid setup. Lots of things are pre-wired, and it's made actually with a good quality cables. The cables are like really solid quality. I brought it out here, so that's what's coming for the installation very soon. For now, I just marked them with my own marks, how it's gonna look for me, but yeah, pretty soon, once it's done inside, it's gonna start to grow here. And lots of work here, lots of wires, having fun, installing switches, installing lights, connecting wires, and hopefully within next week to connect battery and to finally get the magic smoke, right? Without magic smoke, nothing works. So if there is no magic smoke, I'll ask my wife Kate to bring a smoke machine and just run it here. Anyway, just kidding. So that's how it goes for now, and not so many updates elsewhere. Fuel system is under the construction as well. Like fuel system is growing up slowly, but good. Oh, got this thing installed right for the cabin heat. Soon we'll manage to install those two pipes, which will actually bring the wiring from the floor up in a protective way. Those guys are installed now. We need to add more switches here. Yeah, those guys, they look awesome. I don't like it. So that's pretty much the status for now, and well, see you later with more updates on this Murphy Moose airplane, which hopefully will take its maiden flight in 2026.